Hello everyone, welcome to Learning at 11th Hour. So in the previous video, we've seen about the excitation table and the characteristic table of flip-flops. Looking at the underlying structure of flip-flops, we observe that the basic structure remains pretty similar for all the four flip-flops. In that case, it is possible for us, therefore, to convert from one flip-flop to another. So how do we do that? So this is a very simple four-step process which I'm going to take you through. Let's dive into the video. So flip-flop conversion is a simple four-step process. Let me take you through these steps with the help of an example. Say I want to convert the JK flip-flop into a T flip-flop. So how do I do this? Let's look at the first step. We need to note down the given flip-flop and the desired flip-flop. The given flip-flop in this case is going to be my JK flip-flop, and the desired flip-flop in this case is the T flip-flop. After having identified this, let's move on to the second step. We need to write out the characteristic table of the desired flip-flop. So here we have T as our desired flip-flop. If Qn is the present state, Qn plus 1 is the next state. Suppose I have knowledge about T as well as the present state, then what would my next state be? This is what the characteristic table would be, right? So if this is my first step, this is the second step. Here, looking at the characteristic table of T flip-flop, we know that whenever T is 1, Qn will be complemented in the next state. Otherwise, it will remain the same. So here, Qn will be maintained. Here, it will be toggled. So this turns out to be our second step. The third step is we now need to consider the present state and the next state values of this table. So this is the present state, and this is the next state value. And now we need to obtain the excitation inputs of the given flip-flop. Here the given flip-flop is JK. So we need to obtain what we have to excite J and K with so that we have Qn as our present state and Qn plus 1 as our next state. So now we can refer to our excitation table of the JK flip-flop and fill this out easily. So referring to the excitation table, for 0, 0, J and K should be 0, don't care. For 1, 1, it should be don't care 0. For 0, 1, it should be 1, don't care. And for 1, 0, it should be don't care 1. So now we have completed the third step where we have obtained the excitation inputs for the given flip-flop as per the characteristic outputs of the desired flip-flop. We now need to obtain the expression for J and K having known T and Qn. So right now we have to ignore our Qn plus 1 column and just consider T, Qn, J and K. So we are going to draw K maps, this being the third step. The fourth one is obtaining J and K expressions with the help of K map. So K map for J in terms of T and Qn. So it's just a two variable K map. So this is T, this is Qn, 0, 1, 0, 1. So here when T and Qn are both 0, J is 0. When Qn is 1 and T is 0, J is 1. So T is 0, Qn is 1. Here J is don't care. And we've got one output over here for J where it is 1, 0 for T, Qn. And for 1, 1 again it is don't care. So we know that we can't have a group of just don't cares. So we are going to group these two together. And the expression that we obtain is T. Again, we need to obtain the K map for the K input. So here we have again T and Qn, and we are going to refer to the K column. So for 0, 0, K is don't care. 1 0, K is don't care, and 1 1, K is 1. So 0 0, 1 0, and 1 1, K is 1. So here again, we cannot group don't cares together. So we just have to group this don't care with this one, and the expression we obtain is again T. So we see that both J and K are actually equal to T. So let me show you how we have converted our JK flip-flop into the T flip-flop. So if this is the JK flip-flop that is given to me, this is J, this is the K input, this is Qn, this is Qn bar. Having known this, we see that both J as well as K have to be the T input. So now this becomes our T flip-flop. So here we see that we can extend the clock also out here. So this is our clock pulse. This is Qn, this is Qn bar, and this being the T input. So for this particular dotted box, T being the input, clock being the clock input, and Qn bar being the output. Inside this black box, we see that it's actually a JK flip-flop where both J and K inputs are the same. So therefore, we have now converted our JK into the T flip-flop. So I hope the steps to convert the J and K flip-flop into the T flip-flop, or for that matter, any given flip-flop into any desired flip-flop, is clear to you all. It has been enlisted here. Please do post your queries in case you have any in the comments below. That's all with this video. Thanks for watching.